Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the lecture 5 for the course of Microprocessor Theory and Interfacing. My name is Engineer Jaffar and I'm instructor for this course. So as you know that today is our 5th lecture, and let's start this lecture with a recapitulation of the previous lecture. In the previous lecture we have studied about the instruction set that is used in the microprocessor of 8086. Specifically, we have learned that there are several types of instruction sets actually that can be used and that are used actually in the 8086 microprocessor. So in the last class we have discussed about few of the types. The first type was the data transfer instructions, that if you want to transfer a data or move a data from one place or from one memory location to another memory location, you can use the data transfer instructions in the 8086 microprocessor. Similarly, if you want some mathematical operations or logical or arithmetic operations, for that you can also use arithmetic instructions of 8086. In data transfer mode, we have learned about the very special command that is move, and in arithmetic and several other types as well. But in arithmetic we have learned about add, subtract, multiply, divide, etc. We have learned that how you can use these instructions to get your desired answers. So this was all about the previous lecture. So in today's lecture we will be starting inshallah by using the manipulation instructions, that how you can manipulate a bit. Let's see what is bit manipulation. You see that if you have this data 1 0 and you want to just change this bit, the first bit, so you don't have to input another double one. Actually, you can easily toggle this bit and make it 1 1. So this will save your this energy that is required to transmit this or to process this bit, and you will only need some energy to manipulate this bit. So you have saved a lot of energy, and another processing that is used that would be used in the resending or processing of all these bits. So this is just 2 bits. These are just 2 bits, and imagine if there are 100 bits, and in 100 bits, let's say there are 1 and there are 98 zeros. The number or the frequency of zeros are, let's say, 98. These are 98 zeros, and in the last there is another one. So these make 100 bits, 2 1s and 98 zeros. Now if someone asks you to just change this last bit to 0, so it is very inconvenient and not an appropriate way to retransmit all these 100 bits or process all these 100 bits again. Just toggle this bit. So what you do, actually you take this bits, this data, this memory, and you toggle the last bit. You manipulate this bit. This is known as bit manipulation, in which you can manipulate or toggle one or more bits that is specified by your desired functions at the desired outcomes. If you want your desired outcomes want to toggle these 2 bits, so you can use bit manipulation instructions to toggle these 2 bits. It will become 1 0, and you do not have to actually reprocess all the data or transmit it. That is used to save energy and other processing time as well. So this will be very useful in your coming life, inshallah. Let's start with the detail of bit manipulation instructions. So as I've told you that this bit manipulation instructions, this is used at the bit level. You have to go actually to the bit and reverse it or manipulate it or toggle it. These are the same terminologies, because one cannot become 2, because you know that there is only 2 options for a bit, that is either a 1 or either a 0. So you can see you can call this toggling, you can call this manipulation. These are the terms that are used and that you will be hearing in the future of your life. So these structures are can be used for testing a 0 bit if you want to test that if there is some output or not, or if there is some input coming or not, so you have to actually make a bit to 0, and if it goes to 1 again, so it means that this is the basically testing purpose. You when you always test some data or some circuit, you always apply input. So if you want to check that if the input is correct or not, so you actually give a single bit of the input, so that you will check if the bit is manipulating or not. If it becomes again 0, it means your system is not right. If you are entering a 1 bit and your system is becoming 0, it means that this system is not right. So you can use it for testing purposes as well. It is also used to reset a bit. You see that if this is your microprocessor and if you want to, there are, let's say, 40 pins in 8086, and if there is a reset pin, let's say, or there is any other pin. So the concept of this 8086 actually is that if you want to use a bit, let's say this is the pin of read write operation. Let's say there is a bit of read write operation, read and write. So if you want to use the read and write operation using your 8086, so the first thing you will be needing is that to setting this bit is equal to 1. You will have to enable it, because it will be at 0 potential, and by 0 I means ground or -5, and by 1 I means +5. Let's say this is operating at +5 volts. So you have to actually reset this pin, or you have to set this pin to 1. If you make it 1, then it will this pin will be enabled, and you will be able to process your read write operation. In all these processors and controllers, you have to actually set a pin before actually using it. So you have to set a bit, and for that you will be needing a manipulator that will convert this 0 to 1. And this will the most common terminology or instructions for most of the languages actually set. You have to do this command set. Let's say this is your microcontroller of any, this is generic, this is very generic, and I will tell you that this is let's say you want, there is a light or the input connected to your port number 1 and the pin number 3. Port number 1 and pin number 3, there are actually several ports, and in that specific that port you have several pins. So let's say this is just an example, this is not applicable to this as it is applicable to all of these controllers and processors, but with a little bit of modification. So let's say if you apply this command, so it will enable, or it will set the third pin of the first port. It means that it will make it 1, it will make it high. So if you want to set a bit, you have to actually give it a 1. And by how can you do this? You can do this by these instructions, and you can also use shift bit across registers. We will discussing in the later slides that how this is achieved by the 8086 microprocessor using the bit manipulation instructions. So the first command that you can use for the bit manipulation instruction is actually not set and not source. It basically complements, you know that what is complement, it toggles or it complements each bit of source and produce one complement of that specified operand. So you basically are inverting the source input, this is your input, and you are basically taking the complement of each bit, and that is how you can use you can enable any pin. And because it is basically disable, sorry, and if you set it not, I've already told you that this is a sign for not or negation. So if you do this, your source, you are basically converting or complementing it, or toggling all the bits. So this is the first instruction you can use. This is the specific sign, and that is used for negation. This is used for not specifically, this sign for not. In your logic circuits, you have learned about this sign, that this is a not gate. Whatever inputs you put in, it converts it into, or it take the reverse, or it take the complement, or it toggles it. So this is your not gate. But negation is also of the same concept. It basically negates, but negation is applied on the concept of plus minus. It means that if you have taken +5 or let's say plus 4. So negation of this will will take it or will give you the value of minus 4. But not is not the same thing. In the not concept, this is either 0 or 1. If this is 1, it becomes 0, and if it is 0, it becomes 1. So this is a little bit difference between not and negation. Basically are doing the same thing, but in the different way. This is in decimal or hexadecimal or any other language. Even in the binary, it will convert 1 to 0, but specifically for if you want to do that in binary, this is the specific for binary, that is not source. You can actually take the inverse, or take the complement of the source that is provided to your pin at your microprocessor. Again, there is another instruction for the bit manipulation. You can also use and by using and I will tell you that how you can basically manipulate the instruction. You know that let's first look at the instruction. This is basically and destination to source to destination. So basically you are ANDing these different pins. So let's see what is AND. You know that for an AND gate, you have to actually provide both of the inputs before getting an output. So if you want an output 1, both of the pins should be equal to 1. If any of or either of these becomes 0, you will not be able to find or take an output from that pin. Similarly, these instructions will perform AND operation of source and destination. And source can be immediate number and can be stored in a memory or register or any memory location. You will store this basically this thing in any memory instruction. And this destination can be registered or it can be taken from any memory location. You can see that you can take this destination. Let's say this is destination and this is source. So you can actually take this destination from any register or from any memory location. But you can also take this source from a number. You can also provide it that or you can take it from a register or from another memory location. So these are some important points that you should be keeping in mind. These both operands, and as we have discussed earlier, that both operands cannot be memory locations at the same time, because it will cause a collision overlapping. So you cannot take both of these from the same memory location at the same time. So you will have to basically select one from a register and another from the memory location, or if you are using the memory location to the destination, you can take a register or an immediate number. Let's say some output from another input to this input is provided by the some output of another system or from another gate. So you can use that, but you cannot use memory location for both of these at the same time, because this is not possible. In 8086 we have discussed already this in the previous class, that you cannot use memory locations of operands at the same time. So you see that there are also flags. There are some flags: carry flag, overflow flag, and you have to this will automatically become to 0, because if you are setting it to 1 or if you are setting it to 0, it means that you are not taking you are not adding or subtracting anyone. So there is no need of a carry or a borrow. So you can easily set it equal to 0. You can see that this carry flag has become equal to 0. And similarly this overflow flag, this is the overflow flag. Overflow means that you have exceeded your memory, but you know that you see that there is only a bit. So there is no chance that this memory can be filled, because this is only one bit. If it is 2 bits, then there was a possibility, but in this case, if you are setting a single bit, there is no possibility that this carry flag or this overflow flag will become 1 or they will be enabled. So you can easily take this. You have to make it 0 after the operation. This becomes automatically to 0 after the operation. There are some other flags that are used, and that is also updated with the procedure that is running over here. So these are some parity flags, and you can see that in the previous class, previous lecture of this series, I have discussed some flags over there. Coming to another type of instructions that is used for bit manipulation specifically, the second type of instructions that you will be seeing in your coming classes and your coming life, that is basically OR destination and source. You have to OR the source and destination. So it performs the OR operation between the source and destination, and you know that in OR operation, uh, to get a bit, actually to get a bit, this is the OR operation. To get a bit, single bit, let's say one, you can make it either of them equal to one. You can make it this one, or and this is equal to 0, or you can make this 0 and this is equal to 1, or you can make both of them 1. So in any case, if any of one comes at any input, this will automatically become 1, and you see that you have actually manipulated the data. In this case this is here, and in this case this is here. So you have basically, you see that to take these examples, you have actually manipulated the data. So this is the OR instruction that is used for the manipulation of the data. And again the same thing, that source can be immediate number, register, or any memory location, and destination can already be a register or a memory location. It cannot be a immediate number because you cannot directly access the destination register, because destination register is specifically kept for the outputs, and you cannot directly provide the input to the output register. So that is why you cannot make both of them the same. You cannot use destination immediate number for from a destination for a destination. So there is another point as well, that you can, similar point, that you cannot use memory locations at the same time for the both of the source and the destination. If you are using destination from a memory location, you cannot use another memory location to take the variables or values from another memory location to and provide it to the source. So you have to come up with another immediate number or register, but you cannot come up with the memory location if you are using you are taking destination from a memory location. So you have to pay some cost, or you have to manage this thing, that you will provide the memory location, the data of memory location. It is very easy. I'll tell you how. This thing can be basically coped with a solution, and I will provide you the solution. You can easily take the data from the memory location and store it into the register before actually starting the process. So what you do in this thing, that you take the data from the memory location and make a copy and save it in some register, so that if you are taking the destination from the memory location, it will be very easy for you not to use memory location another for the source as well. You will be taking this value from the register that you just stored in this register. So you will take the data or the value from this register, and this is a very easy process. If you want to and make both of these memory location work, you have to basically copy the memory location to a register and you can use it. This is basically a kind of you can say jugaad, but let's not forget that we are aiming to resolve these things as easy as much as possible. So this is another point, that this is the same point as mentioned above, that carry flag and overflow flag will also be become one after the operation, because you see that this is only a few bits that are basically toggling. So in managing one bit is not much of that, because you will not need a carry or a overflow flag to save these bits individually. So for that you will also not you will also there will be no need to make the carry flag or overflow flag before using after using this operation. And these are some other flags that that will be automatically updated after you have done this kind of manipulation. Now there are some very cool examples of another instructions as well. Let's start with Xall, that is the exclusive OR, and it will provide you the XOR operation between the source and destination. You will know that this is very easy to learn, guys. You just have to follow the truth table. You just have to follow the truth table of any of the gate if you want to learn about how these things, these commands actually work. And I will suggest you to this is basically logics, and all the coding is done through logics. If you want to learn coding, this is the first step, guys, and I've told you again and again, then this is your first course that you will be studying, and in a comprehensive manner, because it use coding, and the basic fundamental or the basic building block of any coding language is the use of logic, and how you can use these logic using these gates, because everything is basically dependent at the end on these gates. So you have to actually understand the purpose and the operation of every gate before using logics actually. So for logic, you will be needing gates, and for coding you will be needing logics. So you see that how coding depends upon gates. This is a very interesting thing, that this coding in any language, it could be in any language, could be in Java, HTML, or PHP, or CSS, or WordPress, or this assembly language, or C++, or Python, you name it guys, and all this coding is basically dependent upon these logics. And if you are able to make the logics, you will be able to write it into a proper syntax. Syntax is different for every other language. Every language uses different syntax, but every language is based on same logics. You will be learning this in the coming years, or 1 or 2, but I suggest you to start learning these logics and gates for now. And in the coming semesters, and by yourself, you can use these gates and these logics to apply into any language, and you will see that it will be very convenient for you if you are able to become or make or develop some logics. You will this will be very easy for you to code in any language, because every language has different syntax, and you just have to follow the syntax. And if you know about the logics, syntax is very easy. Syntax can be copied pasted, but logics cannot be copied and pasted. Logics are something that it basically acts as a mind. You cannot copy the mind, but you can copy the actions. So these are the actions that you can copy, that is syntax, but this is your mind. You cannot copy the mind of any other person, you know that, but you can copy their actions. So actions can be copied. You can copy the syntax of the coding, but you cannot copy the logics of the coding, because it has to be unique for every developer, or every programmer, or every coder. So I suggest you to start learning gates, and these you see that these are just gates. This bit manipulation instructions, or any instruction, these are just gates. These are they are the use of gates. So they are the applications actually of gates. So you see that there is a XOR operation between the source and the destination, and it performs the XOR operation. And similar discussion, that source can be immediate number, register, or a memory location, but the register destination cannot be immediate number. It should be kept from taken from register or any other memory location. And these both operands cannot be taken from the memory location at the same time. And how you will cope this solution, this is my question to you, that how you will be able to cope this solution. If you want to use you have a memory location, and you want your, let me write it down again. Let's see. Let's say you have a memory location, and both the data that you want to manipulate are stored in this memory location, and you apply XOR operation. Now my question to you is, how this is possible for you to use these instructions, this memory locations. Let's say this is memory location, and this is the first part, and this is the second part of the memory location. This is divided in two parts, but it is mentioned that you cannot take memory location at the same time. So what is the solution for this? My question to you is that, what is the solution for this? So if any one of you can answer me, I've already answered actually, so you have to learn very carefully this lecture. If you answer this in the class, I will give you a bonus marks of +1. So let's start, let's go further, and you can see that there is no zero at the same point, that the carry flag and the overflow flag will be becoming 1 after you use this operation, and all the other flags will be updated. There are several other flags, but these flags are mostly used, so that is why these are mentioned.
This is a very cool instruction that is known as shift register, and you can basically shift left. This sh stands for shift and this l stands with the direction, so you have to basically shift the bits of byte or word to the left by count. So it means that that if you are using, let's say, this data, and someone asks you to just manipulate this bit, the last bit. Let's say this is my data, all these are ones, and let's say this is 0 0 triple 1 0. This is your data, and someone asks you to manipulate the last bit actually. So this is very easy for you guys. You can just apply the shift this command, and you can give the command and the count, that how much shifting you want. So you see that to manipulate this 0, I can only shift this 1 at this location, so I need only one count. So I will apply SHL destination and 1. It will automatically shift this 1 to the left. It's actually right, but let's say this is my left, this is your left, so it will shift. Basically left is at this side actually. So if you want to toggle, let's say this bit, let's let's not get you confused. Let's say you want to toggle this bit, that is 0, so you want to move this one at this location. So you see that the count is 1. Now this is okay, count is 1. So if you apply this command, it will automatically shift this one at this position because it is moving left, and this similarly this space will be emptied, and this one will be forced to go over here. Similarly this one will be coming over here, and similarly this 0 will be coming over here, and this 0 which was replaced now will be coming at this side. So you have actually manipulated the data and you have toggled the bits actually of your desired output. So this is basically shift register, shift left actually, or it can shift the bits of the byte. You can see that basically we have shifted the bits of a complete byte. Let's say there are some 3 zeros, this is a complete byte. So this will do the same process, and these zeros will be coming over here. So you have to you have shifted the bits, and if let's say the count is 2, let's go with the count 2. So if the count is 2, this will be shifted twice. So this 1 which was coming over here now will be 1, and it will be going over here. So there will be 0 over here, and this one actually will be going in the last. Similarly this one will be coming over here, this one be coming over here, and this 0 will be coming over here. This will become 0, and all the other things will be 0 as well. You see that this will become 5 zeros and 3 ones, but these ones will be at the corner, at the edges. So this is the bit manipulation instruction using a shift register. And there is another definition of it, that it puts zeros in LSBs, the low significant bit or the least significant bit, and most significant bit is shifted into carry flag. So if the number of the bits desired to be shifted is 1, then the immediate number 1 can be written in the next count. You see that I have already told you that if your your count is 1, you can easily put this 1 at this place, this one at this place. You have actually manipulated the data. And however, if the number of bits to be shifted are more than 1, then the count is put into a CL register. This is your C register, as a low byte of the C register. I have told you in the previous class that we have A, B, C and other registers, and this one will be taken from this memory location, and it will be stored temporarily from to the CL. So these are some cool things that you can do while using these commands. And if I tell you frankly, all the most of the codes that are generated for encapsulation, For coding, encapsulation means you have basically applied some security or some passwords to a file, and these passwords are basically this is known as encapsulation, and most of the encapsulations are done using this command, that is shift register. You actually shift the registers and manipulate the data so that no one can see the data except your computer. Your computer will be taking your input, and it will automatically providing you the by matching it to the password you have already provided. So this will performed by the shift register or the SHL command, but not in every computer. It is we are discussing about 8086 specifically, but the concept is same. If you learn about these things in 8086, you will be easily able to understand that how does it work on 8088 or any other latest microprocessor if you learn about the basic. So this course is about tell you that to make you start about the learning of the basic architecture. So if you are very familiar with this, I will assure you, I guarantee you that this is not difficult for you to learn in the future as well, and it will only take a couple of minutes for you to understand these in the future. And this is not the limit. I say that I mostly said that sky is the limit. Let's say you are working in the future in some big giant organization, let's say IBM or any other big computers like company or organization that uses coding. So by that time, let's say there is another microprocessor that will be in the market, so it will not be difficult for you to understand that what is the logic behind it, because if you learned about logic in this lecture, in this course, this could be applied in any language or any format. The basic thing is use of logic and understanding of that how these logics are translated or interpreted by the processor, and this is used by this is done by the interpreted by the use of these instruction set. And in other coding languages or processors, maybe this code or this syntax, this is actually the syntax. I have already told you that syntax may be changed, or it is definitely changed, but the use of it can be understood by using this very basic and very uh, uh, logical thinking, that you can use this low level, and you will be able to apply on any other higher level language or higher level processor in the future, inshallah. Now there is another bit manipulation instructions that is basically the opposite of the previous one. This is known as basically the shift right. You can see that there is no difference, but the only thing is that instead of moving towards left, instead of moving this side, now you are not doing this, you are moving the bits to the right side. And it is totally up to you that how many counts you want your bits to be shifted. So it actually puts zeros in the most significant flag, and the low significant bits is shifted to the carry flag. And if the number of desired bits is shifted to 1, that then the count is already 1. You see that I've told you that, let's say if you want, this is your 0 and this is your 1, and if you want your this thing to be coming over here, you want to manipulate this bit, so you have already written that the count is 1, so you have to place 1 at this side. So this will move the bits one by one to the right hand side. And you can also shift the more. If you want more than one, you can easily use any count number. Let's say this is not the one, let's say this is 0, and this is again 0, and this is again, let's say 1. So you will if you want to manipulate this bit, you have to actually apply the count of 1, 2 and 3. So we will be using 3 as a count before applying the command. So if you apply 3 over here, this 1 will be shifted over here at this side, at this bit, at this location. There's another very interesting command that is basically rotate left, and it can be seen that it will also do the same stuff, but it use basically the carry flag, the flags actually. This is a little bit different from the shifting. It basically rotates the bit. And what do I mean by the rotates? By the rotate bits, it basically transfer the MSB to the LSB, and also the flag, this carry flag. So this is another very cool instruction that is provided to you by this command, this instruction set of 8086. But this is not that much of mostly used in the 8086, but it is of some kind of use. So this is the command of for another option for you if you want to rotate the bits towards the left. So let's start with the data transfer operations that we have discussed. We have already discussed these things in the previous class. So this is your rotate right command that is used for the bit manipulation. uh, and this is exactly this opposite of the previous one that was rotate left. It is basically rotating it right. So you can see that the LSB is now transferred to the MSB and also to the carry flag. In the ROL, MSB was transferred to the LSB, but in ROR the LSB is transferred to the MSB. So this is a small difference between the rotate left and rotate right. Similarly, shift left and shift right. So this was all about the bit manipulation instruction. So now let's get started with another cool instructions of program execution transfer instructions. So I have discussed with that if you want to execute a total program, so for that you need some instructions, and these instructions are basically we will be learning these commands, and these commands are very much of importance. I'm telling you guys again and again this that be serious with this course, because this is a course which will be helping you in the coming life, inshallah. So the first command that you use for the execution of a program, let's say you have written a whole program, it is a bunch of lines, let's say there is 1,000 lines, there's 1,000 lines of command. So it is not very, let's say there's 1,000 lines, it's not very convenient, it will be not very convenient for you to switch to run all these commands one by one. So what do? You basically store these whole command in some memory location, let's say memory location X, and you just call it, you just call it, and by calling it means that this whole will be read. Instead of you calling them one by one, you are actually calling them as a whole. So this will be calling as a whole. So this instruction is used to call a subroutine or a function or a procedure. You say that this is a procedure, and let's say there are several other procedures that are involved. Let's say when you zoom to this line, it has actually a function in it. So let's say there is a function in it, so it will not be possible for you. I have already given you example that mostly the normal commands are of 1,500 or 2,000 minimum lines, and I will be very happy if you guys start writing at least 50 lines commands and 50 lines code in this course. If you learn 50 in this course, so I will be very much happy, and I will assure you that in the coming lecture, in the coming course of microprocessor interfacing technology, or any other microcontroller course or PLC or industrial electronics, you will be able to write the code for at least 500, and if you keep practicing it, it will be go beyond that. So the more you practice, the more you learn. So this is the basic formula for the learning any language. Learning of any language is not difficult, but only if you use it. If you use you can see that if you use English as your medium of communication, you will be learning English in a very less time. Similarly, if you use the coding as your communication language, so this will be very easy for you, and I hope that you will be learning you will learn this coding in less than 6 months, and you will be able to write a program of at least 500 if you do this with all your dedication and your honesty. This is the thing that I require from you, your sincerity and your honesty. So the first command is call, and this basically calls a whole subroutine or a function or a procedure. Instead of calling them one by one, you actually call them as a whole, and this address of the next instructions call after call is saved on a stack. That what it should do after you have called it. Another very cool function is return, and this will be used in very languages as it is RET, and this is basically the output, that what do you want from that call, what output do you want. So it returns the control from the procedure to calling the program, and every call instruction should have a return. If you call something, when it comes to you, you should give it some output. you need it, you want it to do something, do some task, so it will be also providing you some return. So every call instruction should have a return. It is not appreciable and appreciated if you call something and it comes with the empty hand. So if you call something, you call some destination or you call some instruction, you want some output from it. So every instruction should have ret, should have a return. This should be an any output. This could be any output, but it should be. It could be. There should be some thing that is you are taking from that call function. So for that you need to have some coding that provides that if you apply this thing, it will give you this output. If you apply this line, this will give you, let's say, this output. If you apply this line, you call this line, this will give you this output. So my suggestion to you is, let's start to make a program for a table, just for a table of, let's say, 7. So you have to start, or 11, these are prime numbers. So this is your assignment, just for practice. This is not a particular assignment, this is just for you guys. If anyone wants to start learning coding, in, let's say, this will be done inshallah in 5 lines. So I am giving this as an assignment, that write code for using these commands, or you have to use these commands, only these commands. I have already explained to you the for loop, but for loop is for you can also use this for loop in these commands, but for now just go with the flow and write a table of 7 and 11 using these commands. The call functions, multiplication, thematic. In the previous class we have discussed about the multiplication of codes and multiplication instructions that you can use actually to multiply the data. So just in paper, on paper you have to write. There is no need to apply that even. Just write the code and provide it to me. I will check and I will tell you that how you can improvise that code, how will you can troubleshoot that code. This will be a 5-line or 10-line codes, but it will be a good start for you for now. So there is a command that is known as jump, and you see that this jump command is actually unconditional jump, and this is basically conditional jump. I will tell you that what is the difference between these commands. So in the jump instructions, the jump destination instruction, let's say if you are executing a program, let's say this is your program, let's say this is your program, we are providing the instructions and after you reach let's say this line, you want to skip this line and go to this line directly. So you will have to apply the jump command. It means that you will be jumping from this line to this line. Or let's say if you want to go from this line back to this point, it's this point again on the higher level. So you can also use this jump command and you will be taken to this line number 3. This is line number 3, line number 6, and line number 9. So if you go from 6 to 9, you will be needing jump command if you want to ignore these lines 6, 7 and 8. Similarly, if you want to go from 9 to 3, you will have to skip 1 and 2. So you will be needing jump command, and this jump command will be taking you to this line directly. So this is a simple jump command, and this is unconditional. You just ask them to take you there. Now coming towards the conditional command, conditional jump command. In the conditional jump command, let's say this is your instruction set that you have coded, and these are the, let's say again, the 9 lines. Let's say there are 7 lines, and if you want to, let's say you are at this line, and if you want to check that there is some if you want to check that let's say there is a condition. Let's say if you want to say that if you have done some calculation over here, and you say that if x is greater than 0, I am writing the pseudocode. Actually, this is known as pseudocode. This is not the actual code. This is pseudocode. This is a rough work of coding. The rough work of any code is basically known as pseudocode. I don't know the spelling. Pseudocode. Maybe this is the wrong spelling. I know that, but this is just to show you that this is known as pseudocode. PUE actually. Pseudocode. And what is pseudocode? You write the code in your own words. Let's say I'm at line number 3 and I have done some mathematical operations between the x and y. Let's say there were some variables that I have done calculations over. So if x is greater than 3, then I say that take me to line number 9. Take me to line number 9, or go to line number 9. Go to line 9. But if it is less than 0, let's say, go to line 6. Let's say this is a code. It's pseudocode actually. We go to line number 6. So what does this command will do? So this is basically a conditional jump. You have applied the condition. You, after reaching this line, you will see that what is the value of x. If the value of x is greater than 0, you will be directed towards the 9th line. That will be here. And if the value of 0 is less than 0, the value of x will be less than 0, you will be automatically taken to the line number 6. So this is the conditional command where you apply some conditions before jumping. You have to check, and this is normally done in monitoring purposes. Let's say this is your siren. I'll tell you the example. Let's say this is the line number 9 is your buzzer sound. And you have installed some security things, cameras and motion sensors, etc. And if you want to see that if there is some person or there is some body heat, so you will be keep checking that body heat, and as soon as the body heat, it captures the body heat, it will automatically jump to the buzzer, and the buzzer will be initiated and you will hear the siren. So this is an example of conditional jump. You will be keep looking for the bit that if there is body heat or not. As soon as the body heat becomes greater than 0, let's say x is the body heat, as soon as it becomes greater than 0, means there is some person in the building, so this will automatically jump to the line number 9, and line number 9 is basically, let's say, set buzzer, and you know that set means enable the buzzer, set buzzer. So the buzzer will be automatically on and you will be hearing noises, and this buzzer will show you that there is some body heat, and it means there is some person in the building. So this command is actually a very cool command to monitor any building or for security purposes or any other thing. You will be using this command most of the times rather than this command. You will also be using this command as well, but this will be a very interesting command that will be used if you want to use it. So these are some very cool jump instructions that are provided to you by the 8086 microprocessor. The first one is jump if above. As I've told you that if the carry flag is 0 and the other flag is 0 as well, so it will automatically jump if above or equal. You see that this is basically conditional commands. Jump if above, jump if above or equal, jump if below or equal, jump if carry, jump if equal, jump if not carry, jump if not equal, jump if not 0, jump if parity even, jump if parity or jump if 0. So you see that these are the conditional commands for the jumps that you can use, and there are several other commands. But the cool thing about these commands that these are almost 10 or 11 commands that are used over here. But in other languages, these commands are basically combined, and you can use one command to actually operate or to do all these things by manipulating. Let's say, as I've told you that you are using these jump commands in this instruction, But in actual other languages, in the non this is the mnemonics, or you can say the assembly line program, but in the other languages, higher level languages, you can actually use these, which I already did. So you see that I used less than 0, and if I want to go with another command, if below command, let's say this is basically, what is this is jump if 0 greater than jump if above. So in the other languages, this is not, let's say, if you want to check that if the value is below something, so you will be not you will not have to basically change the instruction, you will only have to change the operation. In the other languages, you will have to just change the sign. So it become very professional and easy. Instead of learning all these or memorizing all these commands, 10 or 11 commands, just to memorize the jump instruction, you will only need some signs, and these signs you are very familiar with. If you want to check that if this is greater than or 0, greater than or equal to 0, so or any value, let's say 10, so this is no need for this command. You will only replace the sign, this sign. You see that we have changed the sign from this to this, and now from this to this, and the other syntax will be remain the same. So this is very cool command. If you want this thing, you want to learn this thing, write this program, write any program for that uses jump instruction. So that's all for today. We will be continuing our program execution instructions in the coming classes as well, because it's a lengthy topic and I want you to be focused and do more practice before actually going in the depth of these topics. If you have any questions, you have two options: either write it down to yourself and ask them in the class, write it down and ask me in the class. And if you are not able to attend the class in for any reason, the first thing I want you to attend the class. Let's say let's say that if you are unable to attend the class, you can also forward your questions to me on my mobile number, or you have my email as well. So you can contact me directly on my email and ask your questions. I will try to make you understand as much easier as possible. So I look forward to see you in the class, inshallah, and answering your questions. And let's see, you know that the more you ask, the more you learn. Thank you very much. That's all for today. Allah Hafiz.